Ever wonder how your phone predicts your next favorite song or how self-driving cars recognize stop signs? It's not magic, it's artificial intelligence, machine learning, and deep learning. These terms are often used interchangeably, but they're not the same. Each represents a different layer in the evolution of smart machines. Understanding the differences isn't just for techies. It helps everyone grasp how these systems shape our lives, from news feeds to medical diagnoses. Think of it like a car, its engine, and a high-performance turbocharger. Knowing what each does helps you appreciate the whole machine. In this video, we'll break down AI, ML, and DL, showing how they connect, where they differ, and why it matters. By the end, you'll have a clear, intuitive sense of how these digital minds work. Let's dive in and unlock the secrets behind the technology that's changing our world. So, what exactly is artificial intelligence? It's a term we hear thrown around quite a bit these days, but what does it truly mean? At its core, AI represents the ambitious dream of building machines capable of performing tasks that typically require human intelligence. This encompasses a wide range of cognitive abilities. This captivating idea has fascinated thinkers and dreamers for centuries, sparking imaginations long before the advent of modern computers. The quest to replicate human thought processes is an age-old pursuit. AI covers a vast landscape of capabilities encompassing everything from logical reasoning and complex problem-solving to the intricate processes of understanding human language, interpreting nuances, and accurately perceiving the world around us through various senses. Fundamentally, it's the broadest concept imaginable, the creation of intelligence in non-biological entities, pushing the boundaries of what we consider possible. Today's AI landscape is largely dominated by what we call narrow AI, which focuses on building systems designed for very specific tasks. Think of applications like playing chess at a grandmaster level or accurately recognizing faces in images or videos. The ultimate, and currently elusive goal is general AI, an artificial intelligence that would match human-level intelligence and adaptability across virtually any task. This advanced form of AI remains largely a concept explored in science fiction, a tantalizing glimpse into the future. In the early days, AI development heavily relied on hand-coded rules, meticulously crafted for every conceivable situation. This approach proved effective in highly controlled, simple environments, but it quickly faltered when faced with the complexities and unpredictability of the real world. The field soon recognized that achieving true progress demanded a paradigm shift. Machines needed the ability to learn and adapt on their own, without explicit programming for every scenario. AI is the overarching framework, the guiding mission statement, and the fundamental foundation upon which all subsequent methods, techniques, and ambitious goals are built. So, when you encounter the term AI, try to think of it as the grand, overarching idea, the simulation of human intelligence within machines. But the crucial question remains, how do we actually empower machines to learn and improve? This is precisely where the fascinating field of machine learning enters the picture. Let's zoom in and take a closer look at this critical component of the AI revolution. Enter machine learning, or ML, a pivotal approach that has revolutionized the field of artificial intelligence. It's become the most successful strategy for achieving AI, offering a pathway to create intelligent systems that can adapt and improve. Instead of programming every rule, which can be a tedious and limiting process, ML lets machines learn from data, empowering them to make decisions and predictions based on patterns they discover. Give the system thousands of examples. The more data, the better it learns. Consider emails labeled spam or not spam. This is a classic example of how ML is used in everyday applications. The system analyzes these examples and it finds patterns, making predictions and improving over time with each new piece of information it processes. MML is fundamentally about learning from experience, adapting and refining its understanding, just like we do as humans. This approach is incredibly flexible and powerful, allowing machines to tackle complex problems. It excels at uncovering patterns humans might miss, revealing insights hidden within vast datasets. It powers the sophisticated recommendation engines behind platforms like Netflix, Spotify, and YouTube. These systems are constantly learning your preferences from your behavior and the collective behavior of millions of other users. ML fundamentally shifted the focus from writing explicit rules to the crucial tasks of preparing data effectively and carefully, selecting the most appropriate learning algorithms. The machine then does the heavy lifting, processing the data and identifying patterns, figuring out complex relationships within the data that would be nearly impossible for humans to discern manually. That's precisely why ML is the driving force behind the vast majority of AI applications you encounter today, from the convenience of voice assistants to the remarkable accuracy of language translation tools. ML isn't a separate entity from AI, it's an absolutely crucial and integral part of it, forming the bedrock upon which many AI systems are built. But within the realm of machine learning, there exists an even more advanced and sophisticated technique: deep learning. Let's take a closer look at this powerful subset of machine learning. Deep learning, or DL, is a specialized subset of machine learning that uses artificial neural networks inspired by the human brain. These networks process information in layers, with each layer learning to detect more complex features. For example, to recognize a cat, early layers spot edges and colors, while deeper layers identify ears and whiskers, and finally the whole cat. The deep in deep learning refers to having many layers, sometimes dozens or hundreds. Unlike traditional ML, DL often skips manual feature engineering. Feed it raw data, and it learns the important features itself. This breakthrough lets us tackle problems once thought impossible, like image and speech recognition. DL powers voice assistants, photo tagging, and self-driving cars, excelling at perception and pattern recognition. It's not a separate field from ML, but the cutting edge of it. Deep learning is the technology behind many of AI's most impressive feats. Now let's see how all these pieces fit together. Picture Russian nesting dolls, those charming matryoshka dolls, each nestled perfectly inside the other. AI is like the largest, outermost doll encompassing everything. It's the overarching concept. It represents the big, ambitious idea of making machines truly smart, capable of mimicking human intelligence. Inside AI sits machine learning, a core component. It's the most successful approach to achieving AI we have today, allowing machines to learn and improve from data without explicit programming. And then within ML, we find deep learning, a particularly powerful and sophisticated technique that uses multi-layered neural networks to analyze data in complex ways. So all deep learning is, by definition, machine learning, and all machine learning falls under the broader umbrella of AI. But the reverse isn't true. It's a one-way relationship. Early AI systems relied on hand-coded rules and expert systems, not the data-driven learning of ML. Machine learning thrives on data-driven learning, constantly refining its understanding through experience. And deep learning takes this concept even further, leveraging the power of deep neural networks with many layers. Deep learning excels in particular at handling complex and unstructured data formats, such as images, where patterns are intricate and subtle. And of course, sound, with all its nuances. This nested hierarchy, AI encompassing ML, which in turn encompasses DL, is absolutely key to understanding the true relationship between these terms and technologies. So, when companies broadly claim they use AI, what they often really mean is they're using machine learning or, more specifically, deep learning techniques. Unfortunately, these terms often get muddled and mixed up, especially in the world of marketing and advertising, but now, armed with this knowledge, you understand the real, underlying structure. Ultimately, AI is the overarching goal, the grand vision. Machine learning is a powerful method for achieving that goal, a proven approach. And deep learning represents the cutting-edge tool, pushing the boundaries of what's possible. Understanding this hierarchy prevents confusion and clarifies the landscape, and it helps you truly see what's powering so much of today's smart technology, from your smartphone to your computer. So with that in mind, let's dive in and look at some real-world examples of these technologies in action. Let's ground these concepts in everyday tech. Your voice assistant, Siri, Alexa, or Google Assistant, is a product of AI, handling everything from understanding your words to responding naturally. Within that, ML powers features like music or video recommendations, learning your tastes from your behavior and millions of others. Deep learning enables face unlock on your phone and photo tagging in apps, recognizing faces from raw pixel data across different conditions. These systems are trained on massive datasets, learning to identify features layer by layer. AI is the overall intelligent agent, ML is the engine for personalized predictions, and DL is the powerhouse for complex perception tasks. All three work together in products you use every day. The car is AI, the engine is ML, and the turbocharger is DL. Each layer builds on the last, creating seamless, intelligent experiences. Now let's use a familiar analogy to make the differences even clearer. Imagine learning to drive. Think of a self-driving car. The grand goal, navigating from A to B without human help, is AI. The car's ability to learn from millions of hours of driving footage, rather than being programmed for every scenario, is ML. Deep learning is the car's intuition, processing raw camera and sensor data through many layers to recognize lanes, pedestrians, and traffic lights. Each layer in the neural network builds a more complex understanding, allowing the car to handle real-world unpredictability. AI is the vision, ML is the learning method, and DL is the advanced technique for perception. This analogy makes the hierarchy clear. AI is the goal, ML is the approach, and DL is the breakthrough that makes self-driving possible. Each step narrows the focus and increases the system's sophistication. Now let's summarize everything in a quick cheat sheet. Here's how to tell AI, ML, and DL apart. Here's your cheat sheet for digital intelligence. AI's goal: simulate human intelligence for any task. Method: rules, logic, or learning. Example: early chess programs. ML's goal: enable machines to learn from data and improve at specific tasks. Method: statistical pattern finding. Example: spam filters. DL's goal: solve complex pattern recognition using deep neural networks. Method: layered, brain-inspired learning. Example: facial recognition from raw images. AI is the broadest. ML is a subset focused on learning, and DL is a specialized, powerful technique within ML. The hierarchy: AI, ML, DL. When you hear AI in the news, it's usually ML or DL at work. Each layer brings more autonomy and sophistication. Now you can spot the difference and see through the hype. Let's wrap up with why this knowledge matters for you. The next chapter is yours to write. We've explored AI, ML, and DL from the big dream to the powerful engines driving today's technology. Understanding these concepts is now part of digital literacy. They shape our world and our choices. These tools amplify human capability, and knowing how they work helps us use them wisely. The story of AI is just beginning, and its impact is growing fast. As these technologies evolve, it's vital for everyone to engage in the conversation about ethics, bias, and the future of work. You don't need to be a programmer to keep learning. Stay curious about the tech you use every day. Ask questions, explore resources, and follow your interests, whether it's AI in art, science, or solving big challenges. The future isn't something that happens to us, it's something we build together. By understanding AI, ML, and DL, you're ready to help shape that future. Stay curious, keep learning, and be part of the story.